Hi there. So this is a recap of what we did in class on Monday. If you were out sick, then this is a chance for you to fill in the guided notes. The guided notes are on Canvas, so you can get those there. We're going to talk about lump sum annuities versus, lump sum investments versus annuities. That's the monetary piece, and then we're going to talk about an introduction to logarithms in a separate video. All right, so pause the video and read the first couple of paragraphs of this guided notes. So you can tell from reading this paragraph, we have two types of investments. The first is a lump sum investment, which we've talked about before, which had this formula. Where V is the value of the investment at the end, P is the principal, the initial investment, R is the annual percentage rate, written as a decimal, N is the number of times it's compounded per year, and T is the number of years. Now, we sometimes write this formula a little bit more simply by letting NT, which is the number of payments, equal a single variable, which we're going to call X, and then R over N, which is that subdivided interest rate. So if it's being compounded quarterly, you divide by 4, monthly divided by 12, weekly divided by 52. We call that the working interest rate. And that is sometimes given the variable letter I. And of course, that's not I, the imaginary number. So then that makes this formula for lump sum investment P times 1 plus I to the X. So we're going to be using that formula sort of moving forward. It's a little simplified version of the formula. Now, lump sums are if you have a whole bunch of money at once and you can invest it. But most people, when they're ready to build money, they don't have a whole bunch of money up front. So what they tend to do is use an annuity. An annuity is where you're trying to put in a set amount every month or every quarter or every week. So we're going to see how this works by looking at a particular situation. So here's how this works. John's going to invest $100 a month. So he walks in on the first day and says, I want to open an annuity. I'm going to put $100 into this annuity. That $100 sits in the account for the month. And then the second month he comes in and says, hey, I'm putting down another 100. But my first 100 has earned some interest. So since he's putting the money in on a monthly basis, you would, just like in the lump sum investment, you would take the APR, which is 0.024, and divide it into equal parts. This time 12, because he's making the payments monthly. That's going to give me the working interest rate for this annuity. So when we calculate how much the interest, the blue payment has earned, it's the 100, and it would typically be times 0.002 plus another 100, but to simplify that calculation, we're going to write that as 100% plus the 0.002% it earned. And of course, I could write that as 1.002, and I'll do that in future steps. So he comes in the next month and says, I'm going to put another 100 down. Well, now the green payment has earned its first bit of interest. And the blue payment has earned another 1.002. So it's multiplied by 1.002 again. So then he comes in and makes another payment. The red payment earns interest. The green payment earns interest again. And then the blue payment earns interest again. So looking at the pattern of what we've written here, I'd like you to just pause the video and try to write out what that fourth payment would look like. So this is what that should look like. Now, if you notice the values, let's look at that fourth month. I could keep doing this on and on, but it's going to eventually get really tedious, right? So it'd be super useful to have a formula for this rather than having to write this out long form. So if you look at this thing we've got for the fourth month, you notice we have a bunch of things added together that all fit sort of the same pattern. And the pattern is we start with 100, and then we multiply by 1.002, multiply by 1.002 again, and again, and again. So this is what we talked about in the last section. This is a geometric series. And remember, geometric series, we're adding a bunch of terms that are basically, you multiply by the same thing every time to get to the next term. Now, the formula that we got for a geometric series looked like this. Now, we got to be careful here because the R in this formula meant something different than the rate, than the APR. So we're going to take this formula, we're going to look at this pattern above, and we're going to rewrite it for money's sake. So if you look at this series that I've got here, the first term is the 100, and the 100 is the same thing as the monthly payment. So let's give that payment a variable name. Let's call it M. Now we're going to write monthly payment here. It doesn't have to be monthly. It could be quarterly, it could be weekly, but we're just going to write that as the regular payment or the annuity payment. That might be a better way of writing it. And for some reason it's not erasing, so we'll just say it's the annuity payment. Now, the thing I'm multiplying by every time is 1.002. And that 1.002 came from my working interest rate, which was I, adding the 100%, so 1.002. So my R in this case is 1 plus I, 1 plus that interest rate, working interest rate, sorry. The N here, again, is different than the N we had up here. That's why I want to write this in terms of like different variables so it's not so confusing. But the N is the number of months. And you could tell if you look at the pattern above, my fourth month ended on a fourth power. My third power was the third month, second power, second month, first power, first month. So that N at the end is the number of months that have passed. So when I rewrite the formula like in relation to money, the value of my whole investment will be all these things added together. So that's going to be V equals my first term, which again we said was the monthly payment. Oops. Times my rate for the geometric series, which was 1 plus I, to the number of payments, which we're not going to call N. We actually gave that a different name. Let me fix that. Remember, we called that up here at the top, we called that X. So we're going to call that X here. So 1 plus I to the X minus 1 all over 1 plus I minus 1. Now you notice the thing on the bottom, 1 plus I minus 1 can be simplified. So when we do that simplification, we're going to get a formula for the value of an annuity, and it looks like this. Where M is the regular payment, I is that working interest rate, which is the APR divided by the number of payments you're making in a year, and X is the number of payments overall, which is calculated by the length of investment times the number of payments you're making per year. So if I wanted to use this to find the value of an annuity after 1 year, I'd take this, I'd plug all the information in, by the way, the number of payments here, 1 year, so there's 12 payments. And then I pull my calculator and do that calculation. And when you calculate this properly, you should get $1,213.29. So it might be useful to go ahead and try that calculation on your own to make sure you get the calculator working. And then we're going to end the video there, and I'll make another video that does the examples in the back of this.